Alright, by now we know pretty much all the rules we need to know. Now it's just a matter of putting it all together. So we didn't really do too much about the zero exponents, the zero exponent law, but we did a little earlier talk about what happens as you get from 5 to the fourth power, third power, second power. 5 to the 1 is just 5, and then 5 to the power of 0 is just equal to 1. Well, that would be the same as any number. If you have 3 to the 4, that's going to be 3 times 3 times 3 times 3. 3 to the 3 is 3 times 3 times 3. 3 squared is 3 times 3. 3 to the power of 1 is just 3. And then 3 to the 0 is just equal to 1. Anything to the power of 0 is equal to 1. Unless there is an exception, like 0 to the 0 is not equal to 1, because that's indeterminate, but that's not something you guys have to know. So 7 to the power of 0 here. Well, that's pretty easy. So it's to the power of 0, so it equals 1. Negative 3 to the power of 0 equals 1. K to the power of 0 equals 1. Anything to the power of 0 equals 1. There is something I do want you guys to notice. This negative 3 to the power of 0. If it had been written as this, negative 3 to the power of 0 with no brackets, well, that would actually be different. That is equal to, so if you notice, it's just, in this case, the 0 is to the power of just the positive 3. The 0 doesn't look at this negative 3. It doesn't have anything to do with this negative. It just has to do with the 3. Because an exponent only acts on the thing right next to it. So this would actually be equal to negative of 3 to the power of 0, which is 1. Negative 1. But when you have negative 3 in brackets to the power of 0, now this 0 is acting on this negative 3, because the whole thing is put together, like it's kind of one package. You package it up with those brackets, and so that is being raised to the 0, which equals 1. So here it's like, for the first one here, the example that I gave, it's almost like two different operations. The first thing you would want to do is the exponent, which is 3 to the power of 0, which is 1. And when you're done with that, then you say negative of that, so negative 1. So be very, very careful. If you're trying to raise a negative number to an exponent, it's really important that you keep your brackets there. And that's going to come up very soon here. Alright? Okay, so power of a power law. Express 9 to the power of 2 to the power of 3 as a single power and evaluate. Okay, so 9 to the power of 2 is 9 times 9. Keep that in brackets. To the power of 3. Well, anything to the power of 3 is just itself 3 times. So you're going to have 9 times 9 times 9 times 9 times 9 times 9, which is equal to, let's see, 9 times 9 times 9 times 9 times 9 times 9, that is 9 to the power of 6. Evaluate, I'm going to let you guys evaluate. That's a little too high for me without a calculator. Okay, so just put 9 to the power of 6 in your calculator. Express each as a single power. So 2 to the power of 3 is 2 to the 3 times 2 to the 3 times 2 to the 3 times 2 to the 3. We already know the answer is going to be 2 to the power of 12, but let's one last time. Let's do it kind of by its definition. So it's 2 to the power of 3 times 2 to the power of 3 times 2 to the power of 3 times 2 to the power of 3. And each one of these, so that's 2 to the 3 raised to the power of 4, so it's times itself 4 times, just like any other power. And inside the brackets, you have 2 times 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 2, which equals 2 to the power of 12. I can do this one in my head. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096. You guys can double check that for me. There you go. And this one I'm just going to go straight to the answer. It's going to be 4 to the power of 10. I don't know if I could do that one in my head. No, that's getting a bit too high. You guys will have to do that one in your calculators on your own. Okay, power of a product law. Okay, now I got some letters in there just to kind of show that it doesn't really matter if they're numbers or letters. The same rules apply. So I'm going to do it the way I like it first. 4a to the power of 3 squared. So that means times another 4 times a to the power of 3. If you expand that, you get 4 times a times a times a. That's the first bracket. Times 4 times a times a times a. So if you notice, you get a 6 times and 4 twice. So it's not just 4, it's 4 times 4. And a to the power of 6. So you end up with 16a to the 6. Alright, part A. 3x squared. So notice, it's not just the x squared that's being raised to the power of 5. The 3 is in that bracket too. So everything in the bracket has to be raised to the power of 5. So 3 has to be raised to the power of 5. So keep in mind, this is going to be 3x squared, 3x squared, 3x squared, dot, dot, dot. Okay, there's going to be 5 of them. So there are going to be 5 3's. So that's why I have 3 to the power of 5. 3 times 3 times 3 times 3 times 3 times 3. You have x squared, x squared, x squared, x squared, and x squared. So you're going to end up with 10 x's. Right? You have 2 in each bracket, and there are 5 sets of brackets. Okay? And this is equal to, gosh, I don't know if I could do this one. Let's try it. 3 times 3 is 9. Another 3 times 3, that's 81. 243. X to the power of 10. There we go. Alright, and part B we have, now, notice that the negative is on the inside of this bracket. So that negative 5, it has to be raised to the power of 4. Not just 5 being raised to the power of 4, but negative 5. So this would be wrong. If I wrote negative 5 to the power of 4, that's actually incorrect, because that's not saying that the negative 5 is supposed to be raised to the power of 4. The only thing being raised to the power of 4 is the 5, and then you do the negative later. But this negative 5, if you notice, is inside the brackets. So you need that whole thing to be raised to the power of 4. So this is negative 5 in brackets to the power of 4 times y to the power of, let's see, there are 3 y's on the inside of the bracket, and you're going to have 1, 2, 3, 4 brackets. Each one of them is going to have 3 y's, 3, 6, 9, 12 y's. There you go. 3 times 4 is 12. Now this equals negative 5 times negative 5 is positive 25, times negative 5 is negative 125, times negative 5 is positive 625. Not negative 625. Okay, for those of you who forgot to put brackets around here, your answer would have ended up being negative 625 because you forgot that the negative should be raised to the power of 4 as well. When you multiply a negative times a negative times a negative times a negative, so 4 times, it ends up being positive. But if you forget to, if you just do negative 5 to the 4, y to the 12, then and you put this in your calculator is going to do BEDMAS, which means the exponent's going to come first. It's going to do 5 to the power of 4, which is 625, and then it's going to do the negative of that. Well, that's wrong. You need those brackets so your calculator knows that it's the whole negative 5 being raised to the power of 4. So that's one thing to be careful with. That's how I'm going to distinguish between the level 4 students and the level 3 students. The ones who can get that extra little bit are the level 4 students. Okay, so number 6, let's check it out. Express each as a single power and evaluate. Okay, well, we've already talked about negative powers. This is just going to be 1 over 3 to the power of 5, which is 1 over 3 times 3 times 3 times 3 times 3. See, 3 times 3, I think we did that, is already 1 over 243. There we go. 4 to the 3 divided by 4 to the 5. that is going to be equal to, well, I know there's, if I were to write it out, I just always like to, I don't actually write it out like this when I'm doing it, but in my brain, this is what I see. So I wouldn't actually write this on paper normally, but this is what I'm picturing in my mind. I've got 4 to the 3 divided by 4 to the 5. So this cancels out, this cancels out, this cancels out, and when you're all out of stuff, you just have to put a 1 there. This is going to be 1 over 4 squared, which equals 1 over 16. There you go. And this next one, 2 to the power of negative 2 to the power of 3. Alright, so 2 to the power of negative 2 is 1 over 2 squared. And that is in brackets, and you have to raise that to the power of 3. So that means you have to multiply that by itself 3 times. So it's 1 over 2 squared times 1 over 2 squared times 1 over 2 squared. So on the top we just have 1 times 1 times 1, which is 1. On the bottom we have 2 times 2 times 2 times 2 times 2 times 2. That's 2 to the power of 6. And that equals, that could also be written as 2 to the power of negative 6, because they say write each as a single power. Maybe they like to have the power on top. But either way, 1 over 2 to the 6 is just fine. And that is equal to 2, 4, 8, 16, 32, 64. 1 over 64. There you go. Well, this one's easy. This just equals 1. Anything to the power of 0 is just equal to 1. Part B, let's say 6 to the power of 8 times 6 to the power of negative 2. I'm going to rewrite it. Now, there's a lot of different ways. You might have done this differently than me. You got 6 to the power of 8. 6 to the power of negative 2 is actually just 6 to the power of 2 on the bottom. So I'm just going to take this and put it to the bottom with a positive exponent. Now I got 6 to the 2 on the bottom. Those aren't negative, so we can keep them there. 6 to the 2, that's 6 times 6. And you have to do that twice. So 6 times 6 times 6 times 6, that's 6 to the power of 4. Okay? If I were to write out 8 sixes on the top, 6 times 6 times 6 times 6, 8 of them, and 6 of them on the bottom, I know that 6 of them will cancel out, and I'll be left with 2 on the top. So this is simply equal to 6 to the power of 2, and that equals 36. Alright, and now for the level 4 students, here we go. Simplify, then evaluate for m equals 2 and n. Okay, so first we're going to simplify. 2m to the negative 2 squared, so I'm going to do 2m to the negative 2 again, 6n to the power of 5 all over 2mn, and that's cubed, so another 2mn and another 2mn. This, so it looks like I've got 2 2's on the top, 2 squared. I've got a 6 on the top. I have 5 n's on the top. Now I have m to the negative 2 and another m to the negative 2. So that is actually m squared on the bottom. I'm going to actually put m to the 2 on the bottom and m to the 2 on the bottom. Okay, those guys have to get moved down and with a normal exponent, m to the positive 2, a positive exponent. On the bottom, so let's see, so far at the top I did the 2, another 2, that's there. I've got a 6, that's there. N to the 5 is there. I've got my m to the negative 2, which ends up being m squared on the bottom, m squared on the bottom. I've got 1, 2, 3 2's on the bottom, so 2 to the power of 3. And I've got 3 m's on the bottom, m to the 3. I've got 1, 2, 3 n's on the bottom, n to the 3. Alright, so I'm going to reduce it a little bit here. I noticed that this is 2 times 2 on the top, and there's 2 times 2 times 2 on the bottom. So if I had 2 times 2 on the top, and 2 times 2 times 2, I'm just looking at the 2's right now because I know I want to cancel them out. If I have 2 times 2 times 2 on the bottom, and two of these guys, that'll cancel that, that'll cancel that. I'm going to be left with a 2 on the bottom. So in the end, I've got only 1 2 left on the bottom. The other 2 that were on the top and 2 of them that were on the bottom kind of canceled each other out. Alright, I have a 6 on top, nothing on the bottom cancels that. I have 5 n's on the top and only 3 on the bottom. So if I have 1, 2, 3, 4, 5 on the top and 1, 2, 3 on the bottom, 3 of them will cancel out. I'm left with 2 on top. And that's it for the top. On the bottom I still have 1, 2, 3, 4, 5, 6, 7 m's. There is my answer. 6n squared over 2m to the 7. Now I have to evaluate. Sorry about this. Alright, so 6n squared, but we want n to be 1, so 6 times 1 squared divided by 2 times m to the 7. m is 2. So that equals 6 times 1 is just a 6. And 2 times 2 times 2, this is going to be 8 times, because you got 1 here and 7 more here. So 2 to the power of 8. 2, 4, 8, 16, 32, 64, 128, 256. Okay, and that is your answer. Some people might want to reduce that to 3 over 128, because they could each divide a 2 out of them. Either way, these are both good answers. You might even have a decimal as your answer, which would be totally fine. It doesn't say whether it needs to be a decimal or a fraction. Alright, hopefully that helped. This is a long one, sorry about that. I will come back with another video discussing the other assignment from last week.